In this second lesson, we'll look at the critical path method. Critical path is basically the longest path through a project network. Or put another way, it tells you how long the project's going to take. So in this practical exercise, trying to keep things to 8 minutes, the first thing I'd like you to do is set up the project network that you see there on the screen. It has 5 tasks, tasks A through to E. The durations are given here, and the project network you can see here. Alright. I challenge you to set that up on your own. Perhaps one thing you want to do is just make a better name. Instead of calling it Project 1, think of another name. So away you go, press pause, set it up, and then when you're ready, come back to me and I'll set it up. If you're unable to do it, then you can follow me. Alright, welcome back. As you can see, I was just getting things started for you. Right, we'll start from scratch. Welcome back, and let's go ahead. Let's set this up, making sure that we just follow a couple of Microsoft Project setup tasks. One is to remove the timeline here, show all tasks will be automatically scheduled, and finally the project summary task. Okay, here the name might be exercise 2, critical path method. There are 5 tasks, I think. Task A through to task E. And the durations from memory: 20, 40, 10, 20 and 15. And the project network, I might just remove these 2. You shouldn't do this, but just for the purpose of demonstration. The reason why you shouldn't do it is because the entry table here, the one we're working up, is a set of columns that are, it's a template. Okay, if you want to customize your own table, then you create a new table. You can see it here, more tables, and you can set up your own. We cover that later in the lab series. Alright, from the project network, task B was dependent on task A, and task C was dependent on task A. Task D was dependent on task C. Let me just bring that back in line for you so you can see what's going on. And finally, and this is how you put 2 predecessors on one task, this was task E was dependent on task B and task D. And that's that project network that you saw in the previous one. So that's your predecessor or your project diagram. Alright, so here the critical path is the longest path through the network. There are 2 paths through the network. Might just add a name to these. Okay, we'll just format the bar styles. And for our bars, we'll just put a name here so we can colour them, etc. That's not important. I might put the task names to the right, so just name. Okay, and that'll just put the task A, B, C, etc. Alright, and so you can see there's a way of setting this up to customise the view. It's not so important at this stage, or at any stage really. Right, so you can see here 2 paths through the network, task A, B and E, and then task A, C, D and E. The longest path is the one that makes the project take so much time, which is 75 days. And that's task A, 20, B, 40, there's 60, and task E, that's the 75. So the critical path is the longest path through the network. You can identify that by highlighting hiding the critical tasks. Those critical tasks are now in red. The reason why the names come off is because under the format you've got different types of bars, and the one we're thinking about now is the critical tasks. There is the critical tasks. So if I highlight that, I can then add the names back. Oops, just name. Okay, so now I've got both the regular bars with the task name and the critical bars. Well, that identifies the critical path, but it also identifies something about task C and D. Right. For task C and D, can't make that go away, there's a little bit of float there. We'll talk about it more in class, but the free float is the total float for those two tasks, and I think that is 10 days. So from here to here there are 10 working days, meaning that you shouldn't do this, but I will, meaning that I could delay task D. Gives me a nice big warning, don't do this. Okay, without affecting the project. Or I can delay both tasks without affecting the project. Or I can, I can wiggle around task C and task D as much as I want without affecting the estimated duration of the project. Notice how it's just the estimated duration, it's not the actual end date of the project, it's the forecasted end date. So you can see here, delays on task D have low risk, okay, because it's unlikely that a delay will affect the end of the project. Resetting the project. However, should we decide to delay the start of task D, I'll just use this for example. So delay the start of task D by a few days. Now I've forced it to start a little bit later. If there is a delay in the actual doing of the task D by a few days, you can see now, even though there were 10 days free float, an 8-day delay of task D actually does have an impact on the end of the project. So we're taking out any delay that we put into any activity with Slack has a higher risk. Let me undo those things. Should always be start as soon as possible. Okay, and we'll put that, whoops, yeah, it is 3, back in, and it was 20 days. Alright, so what we have now is 10 days total float, so that's our total float. Free float is the amount of time or delay, the number of days that, say, activity C can be delayed before it affects its next activity. Right, so the total float for C and D is 10 days. But if we are going to use this, what we call the earliest start network, the free float for C is 0, because any delay on task C will affect task D. Okay. What we'll do to finish off this lesson is to have a look at a table that indicates those concepts that I was talking about. So under View, who's your friend? We should have a schedule table, and you can see here the total slack or total float for task C and D is 10 days for each. Doesn't mean there's 20 days slack in total, it just means that these two tasks have 10 days of float in which they can be wriggled around. I'll cancel that. Task E has no free float, therefore it must be on the critical path. So the critical path are those activities that have 0 days total float, 0 days slack. For the earliest start, task C has no free float because if it's delayed by 1 day, it'll impact task D. All the slack in the project comes after task D. That's where we've put it all. And of course, that might not be the optimal decision because of resource problems or other risks that we might be taking into account, but at least that's a first good model. So in this lesson, it's not going to let me get back. In this lesson, we've covered critical path method. And a critical path method is made up of a fixed start for the project and no other date constraints. It's task dependencies that determine when a project starts. All tasks are set to start as soon as possible, so you can't wriggle around those bars like I did in the video there. You need to reset everything to as soon as possible. We don't care about resource limitations at all. I'll let you read the rest. The most important bit is non-critical tasks have free float, total float. Critical tasks have no float, and that's how we identify them. Those without float are on our critical path. Alright, let's leave it there.